Hello, this is Greg House from Galactic Gregs. This is the 25th of August, 22. And the view you're seeing, I hope you see in real life come Monday morning at 8:33 my time, 7:33 Central Daylight Time. My friends, this is a simulation of the launch of the Space Launch System, Artemis-I mission. And I am hoping that this becomes a reality Monday morning. Now, I'm going to get all into this, guys. We're going to cover this in some detail. We're going to look at this thing from the standpoint of the actual big picture. This is the Space Launch System. Here we go. Let's have a look at this thing rolling out. I want to show you how big this thing is just compared to people so you can get a perspective. We're about to go into discussions of this rocket, what it is, how it works, what the pieces are, the elements of it, the big pieces. And then we're going to talk about quite a few other things. And this is the first of a series of videos on this Artemis-I rocket and mission. After this video, I'll be doing a video on the payloads. If you don't support this rocket, a lot of people in SpaceX just hate this rocket. And I'll go into that later too. I'm going to be talking about the politics of it, how it got to be what it is, and what the future may hold for this, and the SpaceX human landing system, and SpaceX Starships in context of all this. So hold on your britches, guys. If you're not subscribed to my channel, subscribe, bang that notification bell, and click all, because I'm going to try to give you a video every day here for the next month or two, if I can. You know, there'll be some days I won't be able to do that because I am an exceedingly busy guy, and there may be some days I'll do a couple quick videos because there's so much going on. There's so much happening in space that I need to hit on a few other topics, and this isn't the only thing I want to cover by a long shot. We got a mission here that's talking about being 42 days long. Then it might just be interesting if it don't go kaboom right off the bat, which that'd be interesting for the short term, but a little too interesting in my book. Let's hope it don't do that. Now, you see this guy walking down here? I've got photographs of me with a space shuttle. Here's a guy up here walking. This gives you scale, guys. Anyway, here it is on the launch pad, guys. And it really is on the launch pad right now. Now, that's all sim. It's all simulation, every bit. Even the grungiest part. Pretty good sim here, I'd say. There we go. I just showed you the launch. I'll show you more in subsequent videos. This is the Block 1 initial Space Launch System configuration. And this is what we're launching in Artemis-I and Artemis-II. Artemis-III and subsequent will be Block 1B and Block 2. Now we have 4 Rs25 engines. These are those space shuttle main engines, and we have some solid rocket boosters. Guys, this looks a lot like the space shuttle right here in a way, at least the engine section. It's got the core stage, which was built basically as a derived vehicle or derived tankage from the external tank of the space shuttle itself. Now it is stretched a little bit longer up here because it's got instead of a cap right here, she's got interfaces to all this stuff up here, and it's got engines directly underneath it, unlike the space shuttle external tank, which had engines mounted on the space shuttle orbiter itself. And there was only 3, and here there are 4. And there's also these 2 solid rocket boosters, but unlike the solid rocket boosters of the space shuttle area that gave you like 3.3 million pounds of thrust, these give you 3.6 million pounds of thrust each and have a total energy deliverable of 25% more than the old shuttle engines. We call it impulse, total impulse. And rockets, specific impulse is how much thrust you get per second. But the total impulse is how much thrust times time you get overall. And that is the, a metric that gets you out there and picks up your velocity, the delta V, which you need to go around the Earth and go into low Earth orbit. So these assist greatly in that matter, getting all this stuff up. Now, initially in a rocket flight, most of the fuel goes to lift and fuel, unfortunately, because it's just what it takes to get all this stuff accelerated. And I'll talk about that more at some point in the future. I'm planning to do a Rockets 101 video, just talking about the various basics of rockets and rocket engines and control systems and things like that. So the avionics are up in here, the main avionics, and we'll talk about that later. There's some down here, and there's also avionics in the forward skirts of both of these boosters. They have their own avionics set. I won't go too much in detail on the avionics because some of that's proprietary, so I got to watch what I say. in any event, so we've got here we got the launch vehicle stage adapter, the LVSA, and it's holding something called the Interim Cryogenic Propulsion Stage. This thing was derived from the Delta rocket second stage, the Delta Cryogenic DCSS, Delta Cryogenic second stage, and it was kind of a derived from the old Centaur stages. This has got one RL10 engine. This RL10 engine, we'll talk about that more in a little bit. That's a restartable engine. This is one that we can start in space and restart in space, just like the old J2 is on the Saturn V. But this thing actually predated. The development of this thing started in the late 50s and was first flown in 1962 when I was a wee 2-year-old lad. But anyway, these, like I said, these Rs25s were the old space shuttle main engines. In fact, they are flying actual space shuttle main engines and discarding some of these for the initial flights of this. And then we'll build new, hopefully lower cost Rs25s. We'll talk about that more in the future here in a little bit. But so here's the Rhine stage adapter. And this is where we're going to have the 10 payloads that are going to fly out. And guys, if there's nothing else that interests you about this rocket, you ought to be highly interested. If you're all pro commercial space and you hate this mission, I'm going to tell you what, there is some really interesting payloads on here. We're going to talk about those in the next video. We're going to talk about the mission itself, but mostly these payloads, because there's some real stories behind these. And one of these payloads was actually developed by a hacker group. So some of you guys think NASA is everything and everything in space is NASA, and the answer is no, not by a long shot. And this will illustrate some of that. So we got Spacecraft Adapter here, encapsulated service module adapters. These basically hold the service module, because the service module is smaller than the capsule itself. And so this all helps the aeroflow as you get out of the atmosphere. As you get up higher, none of that stuff is needed, and all that stuff starts coming off, including the launch abort system. It's only going to be on for so long. And here's the service module, and here's the crew module in which the astronauts reside. And this is about twice as big as the old crew module from the Apollo program that took me into the moon. And you can see those in quite a few museums, including the one at the Space and Rocket Center right here in Huntsville, Alabama, where the crew module wasn't developed, but the rockets were developed, including the old Saturn V. All right, here's the solid rocket boosters. The solid rocket boosters have this aft skirt down here. The aft skirt contains thrust vector control equipment that moves this nozzle, electronics, and a lot of hydraulic systems, actuators. The actual thrust vector control pistons are within this aft skirt, and it's got its own avionics. And this is the aft segment. It's specially designed to feed into the nozzle. You got 1, 2, 3 regular, very similar core stage, except on the outside are similar. The fuel grains in these things are starred and patterned differently to characterize the burn, so that you will actually minimize thrust where you're in the high, the pressure, the part they call high Q, the most aerodynamic pressure in flight. Once you pass through that, these engines will actually pick up more thrust. They have it timed into the burn of these, so they will actually reduce thrust at that point in the flight. Because these things would push the vehicle so hard it would break it up had they not done that. This is the forward segment, which has got the end dome up here. It's got the pressure sensors up here and everything that tells you they're lit it. And it's also igniters up in here. And this is the forward skirt. Like I said, the avionics for this guy is here, and you got a nose cap assembly. In the shuttle version, your parachutes would be up in here. We don't have that in this case. They'd be in here because these are only thrown away. And there would be one less segment on the shuttle booster itself. The Rs25 engines are the, like I said, the old space shuttle main engines. These were in development since the 70s, late 70s, and through the early 80s. And it had many upgrades. You can see this thing has some powerful turbo pumps. This guy is really the Ferrari sports car of the rocket engine world. It has the highest specific impulse of any liquid rocket engine that's been of any practical use, and over 425 seconds, which is pretty darn near the theoretical limit. But it's taken a lot to keep these engines going and maintain them. It became recognized as a lot bigger job than what people had thought this would be. See what happens to the thrust here. The fuel and oxidizer get pumped into the combustion chamber, expands and produces the thrust in here. And there's coolant that comes back around and comes back to this preheated. I'm not going to go all in today. I'll do a future lesson on rocket engines where we'll talk about this. This is the, I'll do a rocket 101 course, maybe or video. I might do a series of them. But anyway, this is the RL-10 engine. Like I said, this thing first flew in 1962. And here it is being tested in a partial throttle, it says. And let's see here. Let's look at some of this other stuff here, guys. Avionics. This is the test lab here. I think that's the hill. I think that part, that's either Boeing or that's the hillside for, let's get Jacobs. This might be in 4205. This may just be the hill piece that does the avionics for the actual boosters themselves. But the big main rings for the CITF and SIL facilities, the Integrated Avionics Test Facility, SIL being a system integration lab, are a lot bigger than that. And it mimics how the avionics are laid out in a rocket. And you may have seen, some of you, my friends, a picture of me in there somewhere. I'd have to dig it out in that facility. Anyway, so we got flight computers, engine flight controllers, booster avionics, and the core stage avionics. Core stage avionics is really the flight computers in that. And there's a set of 3 flight computers that make up a functional operational block called, FCOG, and they all work together. They don't have the same kind of, they do have a voting architecture, but there's not as many voting as there was in the space shuttle days, which had, I believe, 5. So this is a little different scenario here, guys. It's set up differently. I'm not going to go all in that because I don't want to stomp on proprietary data here. Let's see. Let's pull up some other fact sheets here. That's the space shuttle main engine that became the Rs25 for this booster. Now we're redoing it. Is it compared to the Statue of Liberty? Right, that's the Saturn V. That's the SLS. Saturn V was just a wee bit taller, but than the Block 1 at least. This is the Block 1. Block 2 will be taller yet. So what we got? We got 8.8 million pounds of thrust. Saturn V had 7.5. The space shuttle had 7.8. And this has got 8.8 million pounds of thrust. This is kind of a cutaway view. This is the most powerful rocket that will ever be flown as of Monday, should it fly Monday. Here's your RL-10 engine. This is the upper stage. Pardon me, I got it wrong. This is the service module. This is crew module. This is the interim cryogenic propulsion module. This is what sets you on the way to the moon after you get in low Earth orbit. So it takes a lot of fuel, a lot of rocket stuff just to get this stuff up in Earth orbit. And this little thing kicks the sky off to the moon, believe it or not. Because most of the work is just getting in low Earth orbit. Now, by comparison, see this again, 7.5 million on the Saturn V, about 7.8 million on the space shuttle. The entire orbiter was really a payload. So that's why the Saturn V was really a heavy lift launch vehicle. And SLS, 8.8 million, actually it's 8.872, almost 8.9 million pounds of thrust available. Now the Starship will give you 11 million pounds of thrust. If you were to build my SRB-5 rocket, you'd have 18 million pounds of thrust. The Long March 9 may exceed the booster on the Starship. So that is something we'll have to, super heavy booster Starship. That is a possibility. That's what they're talking about. And we got the Block 1 configuration here, which has got the 5 segment, solid rocket boosters. Then they're going to put a bigger stage, upper stage on here, the exploration upper stage, which is going to have 4 RL-10 engines, which can carry a lot more payload. It shows a sample payload. You could actually carry a lander inside of this, kind of like Apollo did, if you so chose. But we're going to use the Starship lander because it can land so much more, and apparently it's cheaper than developing another lander by a long shot, even though we're going to have to do a lot more launches to make it work. So, but that's it. The Starship is going to have some enormous advantages, and this program's helping to pay for its development as a landing vehicle. So for those that hate this program, Starship's part of it. And this program needs the SpaceX Starship. Now this is a depiction of a cargo fairing. The whole thing is carrying a big cargo. and it's got the advanced boosters on the side. You know, I wished it would take this and make these flyback boosters eventually and have a returnable engine package if they continue with this kind of configuration, save a little cost, and maybe take this thing into orbit and find some use for it up there. And that would mean a lot more payload to orbit and recovery of some systems. That would help reduce some of the costs of this system. But if Starship works, then it will probably eventually replace this entire rocket if it works as nearly as well as advertised, as we hope it does. All right, guys. So kind of look at this against a family of other rockets. This thing will increase in thrust as it grows. And in fact, it will be more thrust at the cargo. SLS Block 2 will have more thrust in the Starship if this thing is ever built. 11.9 million pounds of thrust. Of course, it won't match Starship 2.0. Elon Musk has got plans for Starship 2.0, which would be stronger and more powerful than the Long March 9 and its reusable Long March 9, which apparently is a stolen concept from SpaceX. So Chinese are actively stealing ideas from SpaceX. They've already stole the Tesla robot apparently, and already released their carbon copy of that apparently. So watch out. The Chinese don't develop, they steal. So watch them, guys. Well, at least the Chinese Communist Party. So this is the iterations of the development. That's cargo versions, the crew versions here and here. This is Block 1, the Block 1B with the exploration upper stage, and there's a cargo with exploration upper stage, and then we got, don't show cargo with Block 1 by itself. The Block 2, it's got these evolved solid rocket boosters, and both of these get 11.9 million pounds of thrust. That's a lot more thrust, a lot bigger payload fairing up here than the Saturn V had available to it. So you could, if you needed to, carry a lander in here should there be problems with Starship. But if there is Starship problems, we're going to have delays of many years here. In which time maybe they would get their stuff fixed. It's too bad Congress didn't fund multiple landing options at the same time. NASA originally really wanted to do two, at least up to some point, and Congress chose not to fund that. NASA went with the cheapest system, which is SpaceX, which also will provide the most capability should it land, and hopefully is developing a long-term capability overall, because guys, rockets like this are not going to get us to the colonization of space, which I want to say. Here's the Saturn V. It gave us 7.5 million pounds of thrust. S1C first stage. There's your second stage, and the third stage is called S4B because it was actually intended to be the fourth stage of what was going to be the Nova rocket, a lot bigger rocket when we're looking at a lunar direct type mission. And what we're really flying Monday is kind of analogous to the Apollo 4 mission. But our very next mission of this rocket will be analogous to the Apollo 8. We're going to send men to the moon, around it, not landing on it. The third mission, it's kind of like we're skipping a mission or two in here. The third mission is intended to be an Apollo 11 mission. Artemis-3 is intended to land on the moon. So Artemis-1, around the moon, uncrewed. Artemis-2, crew around the moon. Artemis-3, landing crew on the moon. And the Artemis program talks about building stuff. We're going to go all in that in the future. We're not going to belabor this much more. I've kind of gave you the basics on the rocket. So here, look at Apollo 4. Complete success. Look at that, guys. Look at that. Back when I was just a lad. Here's the thing, guys. We are on the verge of going back to the moon. For the first time in almost 50 years. The last time we did this, I was just a mere 12 years old with anything nearly this size. And back in the day, I was convinced I'd have my honeymoon on the moon when I grew up and got married. Little did I know the space program was just going to start going around circles around low Earth orbit. So finally, we're getting out of low Earth orbit. We're about to go somewhere, guys. And for that, I'm highly excited. Stay tuned. I'm about to go into the mission. I'm going to go into the payloads, and then we're going to come back and talk about politics in the future. I may cut this up different ways, but I got several more videos hopefully to do prior to the launch. Now on launch day, I'm going to be on console, which means I'm going to be on console maybe for over 12 hours. I'm not going to be able to get this computer running and have it shut down within the YouTube required 12-hour window. If they will allow me to run it from this computer and play it, leave this computer playing, it's going to have sound for y'all to hear anything. If they're okay with it, since there's not many people in my corner of the building, I might maybe be able to live stream this. No promises though. No promises. That will be secondary. You won't see me manning it. I might occasionally be able to pop in and go to my phone and give you a hi. But if I can do that, I will. But at the very least, after launch, I would have been up for a very long time. I got to stay up all night Sunday night. So at some point Monday, I will come on and give you a recap of the launch, how it went, or the no launch, as much as I'm, want to be free to talk about. There are proprietary data involved in this, because we're dealing with contractors like Boca. So there's some stuff I just can't talk about, not because it's top secret, because it's proprietary. And if I break proprietary rules, I go to jail. I don't want to go to jail. So there we go. So backup launch dates are September the 2nd and September the 5th. I pray this launches for September the 5th, because I got another business. I sell wormhole generators. Yes, honest to God, wormhole generators. They do generate wormholes, and I sell them by the pound mass. And I can't deliver them this coming weekend, so I'm shutting sales down for this week. And I hope to goodness this thing launches so I can go back into the wormhole generator business and harvest wormhole generators the following Sunday. If not, well, I can do it the following Sunday, but the one after I'll have to shut down if it is 2 delays. But they say the third time's a charm, but I hope this time, the first time's a charm. Just like Apollo 4. Cross your fingers. Let's hope this thing flies and flies straight and true, whatever you think about the politics of it. And we'll go into the politics, and I'll explain in an objective, non-biased, non-partisan way, both sides of it. And oh yeah, I'm eminently qualified to talk about the politics of it, because I played a big hand in it myself. Because, ladies and gentlemen, I was the chairman of the policy committee of the National Space Society for 10 years. I was intimately involved in this, and I think I was one of the most, believe it or not, one of the most influential people in the choice of having both a private and public segment in our space program. And here's the article I wrote on it 12 years ago in this magazine. Had Asteroid article, and I've always Greg's Galactic Greg's. I've always alliterated. It goes way back. Concerning constellations, cancellation, Congress, and camels. Yeah, and every bit of that got worked into this article, including the camels. When I talk politics, we'll talk about this. I have been quite involved in space policy for many years. So there we go, guys. In addition to building rockets. And some people say, Greg, you're a worm farmer. What do you know about rockets? Quit talking about rockets. No, I am an engineer. So this is a rocket motor that I was involved in developing, one of many. As a hybrid rocket, Cat's Prize hybrid rocket motor. And for those of you that just happen to wonder, this thing's aged a bit. Yeah, there's my college degree from the University of Alabama in Huntsville. Bachelor's of Science, Electrical Engineering, and I've done tons of rockets and things like that. So I've got a long experience in this area. And my mentors, the guys who were my mentors when I started out with the guys who developed this system. So I've worked with these guys, and it was a valuable experience. Just hope that I can pass this stuff off as much as possible to the next generation, the good stuff, the better side of it. So anyway, friends, thank you for watching. More to come. Hope I'll be a little more succinct when I get into the mission and payload video. And so some of these videos will be shorter. And I'm going to be doing like probably a video a day, but as close as I can. I'm not always necessarily going to cover this topic. There's a bunch of other stuff going on. And SpaceX has got a lot of exciting news. There's a lot going on there. I need to get some of that, including, hey, they got a bunch of new customers coming up. Yeah, things are exciting all over, but they're also challenging. There's a lot of challenges. SpaceX is having challenges, and until we launch this thing and it gets back from the moon, I got my fingers crossed. No, I'm not superstitious, but guys, every rocket flight is risky. Every rocket flight is enormously risky, and always will be. So, but hopefully, as we get better and better at that, risk will go down. But I came up with this saying back when I was developing these rockets. Allison's laws of rockets. 1, rockets go boom. 2, rockets have always gone boom. 3, rockets always will go boom. Our job is to make them go boom less often. Hopefully, a lot less often, like very rarely. But hey, you get in a car, who knows, guys? Cars aren't safe either. So there we go. Enough said for that. More on all that in the future. And I might even do some videos and even courses down the road on rocket safety, avionics safety, risk management. That may be some areas I go into because I have worked that stuff. I worked rocket design. I worked avionics design. I worked software design. I worked space station design. I've done strategic defense initiative. I worked on missile defense. I got industrial designs and factories that are all over the country, industrial parts washing machines. I have worked on M1 tank, M1A Abrams. I have worked on the F-15. Yeah, I've worked on the robotics system on the International Space Station. I did the layout for how things are laid out electrically and pins and stuff on nodes 2 and 3 in the International Space Station. Yeah, I've got quite an experience and background in a lot of these areas. So guys, hang on your hats, more to come. A lot of these YouTubers, that's all they do. They just YouTube and they give you little summaries of stuff. I've been there, done it. So latch on and let's go for a ride. My videos may not be as fancy because I still have a day job. I've got that wormhole generator job. And I grow Boca greens and I'm building a mushroom house. And I got 2 YouTube channels and I don't ever sleep, I'm insane. So yeah, you're not going to fancy videos here, but you're going to get some perspective that you're not going to get anywhere else. So hang on, guys. Subscribe to my channel, bang the notification bell, and share my videos. Let's get this stuff out there, guys. Thank you for watching. And with that, I'm going to say, regular.